Good morning, guys. Yesterday we have completed the optimum design part with some examples. Okay. Also, we have completed the theory part, DFA, design for assembly and design for manufacturing. Today we'll going on the next part. Okay, design for forging. What is mean by design for forging? Forging is the process of shaping heated metal by the application of sudden blows. Okay, there are two types of the forging. First is a hammer forging or second is a press forging. In the hammer forging, there is a suddenly blows, means the load or impact is coming suddenly with the help of hammer. And second, in press forging, there is a we are applying the steady pressure on the in the press forging, and it is make use of the characteristics of plasticity of the material. Whatever may be the method of applying pressure for shaping the metal, okay, the primary requirement is to heat the metal to definite temperature to bring it into the plastic state. The primary function you should bring into the plastic state. Okay, then see, the requirement is to heat the metal to definite temperature and to bring it into the plastic state. This may be done in open heat known as a Smith forge. Okay, for a small job or in close functions for bigger job. Nowadays, the forging is an important industrial process. It is used to make the variety of high strength, then again this is used in the component in automobile, then aerospace and other so many applications. For example, it is used to making the engine crankshaft, okay, then connecting rod, then gears and jet engine, okay, then turbine parts and aircrafts structural is used in the forging. Okay, then we'll going on the next. What is the advantages of the forging process? Okay, the forging process can be used for a small components. For example, gudgeon pin we have seen, it is also called as a piston pin, to large component as a crankshaft. It refines the structural of metals. Okay, it refines the structure of metals. Again, next advantage, it makes the metal stronger by setting the direction of grains. Okay, less time is required to complete the operation because of cavity. It required the less time. Okay, it reduce the scrap. Okay, in other operation we getting the more scrap, but in the forging process you will get the less scrap as compared to the other methods. Okay, the dimensional accuracy is obtained, the product is good. Okay, and you will get the good dimensional accuracy because of cavity. Then next, design, there is a recommendation are given, forging drawing and parting line, and one more is a draft is there. Okay, we'll see one by one. What is the draft or what is the parting line? The parting line is when the die helps join together and confine metal in their cavity. The joining line of the die helps around the edge of the forging surface is called as a parting lines. This is called as a parting lines. While designing a forging, the profile of that forging and the profile is selected in such a way that the fiber lines are parallel to the tensile force and perpendicular to the shear force. We will see some examples. See in that example, these lines, while designing a forging, advantages should be taken. The profile and the profile is selected in such a way that this profile is a parallel to the tensile force and perpendicular to the shear force. The forged component should be provided with the adequate draft. Okay. Next, to prevent the drill from the breaking the surface at which drill centers have given. See, there is some parting lines given. With the help of that lines can make the cavity, and also you will get the better quality in the forging. Okay, remember that. For example, ribs is there, bosses is there, webs is there, recess is there. It is recommended to avoid the too high and arrow ribs and also the bosses for easy metal flow. This is shown in the figure. It becomes very difficult when large amount of the metal has to be moved out of relatively things in the web to such projection. See, there are some examples are given for the forgings. Next, see here is I have already told, to prevent the drill from the breaking the surface at which the drills enter and leaves out the work. Means this drill should be parallel and perpendicular to that surface. I have shown the both images. One is the incorrect image, another is a correct image. Okay. Then second, again we have to blind holes must be provided with the bottom recess of the tool. Use that method and do the better forging. Okay. Next is a design for safety. Design for safety. Okay. Design for safety is related to reducing the safety and health risk. This is important through the good design of the object. There are 4 design product for the factor of safety: hazard elimination, hazard reduction, hazard control, and again damage reduction. Then how to do that? Okay, in increasing cost or increasing effectiveness. How to increasing that effectiveness? With the help of one by one we will see. First is a hazard elimination or safe design. This type of design help to eliminate all types of the damage. Okay, this type of design is used to remove the all types of the damage. If it is incorporated early in the system design process, hazards are often limited, almost no cost. Almost there is a no cost. Then next, it can be achieved by the substitution, simplification, avoiding human errors, reduction of the hazardous condition, etc. Okay. Then second is a hazard reduction or design with a safeguards. Hazard may be reduced by using various safety devices. Okay, there are various safety devices. With the help of that you can reduce the hazardous. This safeguards detects the hazard or condition and take the corrected action in it. It can be achieved by the design the system controlling, considering factor of safety and margin. With the help of that you can reduce the hazardous. Third is a hazard control or design with margin. Okay, how to control the hazards? In this type, the hazards are not completely eliminated, but it can be controlling adequate warning in the form of flashing light, or we can use the sounds and banners. Okay, will use that thing and control the hazardous. And this is the warning help to warn the user about the possible dangerous. Okay, you can aware with the help of that sound the possible dangerous. And last is a damage the reduction. Damage reduction is carried out at point when there is a no chance to recovery of the product is possible. Okay, there is no any chance to recovery of the product is possible. This is the design of safety. All of you remember that four terms. Okay, first is a hazardous clamination or safe design. Second is a hazard reduction, or we can say the design with safeguard, hazard control or design with margin, and last is a damage reduction. Okay, there are some parts, then we'll move to the next one. There is a design consideration in casting. Okay, you know, the yesterday we have seen the design DFA and DFM. Okay, today we'll going on the next bit, design consideration in casting. Which consideration will consider for the design in casting? Design the part that shape is cast easily. Okay, whichever shape will cast, this will be cast easily. Select the casting process. There are different casting process. You should select the correct one. And material suitable for that part. Okay, you should also, important is a material selection. Okay, should select the correct material or suitable material for the part, size, mechanical property, etc. You have to take care of the property. Locate the partning line of the mold in the part. Okay, you should locate the partning line. We have seen in the forging what is the partning line. Okay, then again locate the design the gates to allow the uniform feeding of the mold cavity with molten metal. Okay, molten metal you should use that there to locate at the design gates to allow the uniform feeding. Uniform feeding is very important when you doing the casting. Okay, select an appropriate runner geometry for the system. Select the appropriate runner for the geometrical system. Locate mold features such as a sprue, screens and risers and appropriate. Okay, I have shown the some examples. Okay, there is a corners and angles and section thickness are given. Okay, in that remember that to avoid the using sharp corners and angles. Okay, this sharp angles and corners are acts as a risers and may cause cracking and increasing the stresses. Okay, that's why you should avoid the corners and you have to use the fillet with radii ranging from the 3 mm to the 25 mm. Okay, here is some poor activities shown, and in the second row, B row, I have shown the good activity. Okay, some examples are given. Okay, then there is all of you getting the casting. Okay, then see there is a flat areas are given. Okay, there is a large flat areas are given. Plain surface should be avoided since they may wrap during the cooling. Okay, if the material will be cool, then this material will be wrap because of temperature gradients. Okay, that's why you should use the develop the poor surface finish because of uneven flow of the metal during the pouring. When you pour the material, then you will get the uneven flow. Okay, to resolve this, one can break up flat surface with staggered ribs. You should use the some ribs. Okay, this is the casting, design of casting. Next is a design of machining. Okay, design of machining. What is the design of machining? Machining is the manufacturing process by which part can be produced to the desired dimension, and the surface finishing from the blank by gradual removal of the excess material in the form of chips with the help of sharp cutting tool. Almost 90% of the all engineering components are subjected to the some kind of machining during the manufacturing. Already we have seen that things. It is very important to design those parts in such a way that would lead to the increase the efficiency of the machining process. Okay, enhancement of the tool life and reduction of the overall cost of the machining. I have given here one example. In the, if you have seen in the example, there is a machining. There is a two types of the machining. First is a traditional machining and second is a non-traditional. Okay, in the traditional machining again we are using the CNC, and second is a abrasion. Okay, abrasion is there, or we can see we are using the different types of the machines: turning, milling, drilling, planing, shaping, broaching, gear cutting or boring. Okay, under the chip removal. And second is the abrasion under we are using the polishing, buffing, lapping, grinding, honing and surface finishing. And non-traditional way we are using here abrasive jet machining, ultrasonic machining, water jet machining, magnetic abrasive finishing, and next is a erosion. In the erosion, electrochemical machining, electro discharge machining, laser beam machining and plasma beam machining we are using under the erosion process. Okay, this is the design for the machining. With the help of that example, you can explain the machining which is the traditional way and non-traditional way. Again, in the traditional way there is a chip removal and abrasion is there. Under chip removal you should take any one machining and explain. Then non-removal there is a abrasion and erosion is there. Okay, with the help of that too you should explain anything. We have completed in today's lecture all the theory parts given in optimum design. Okay, from that bit, design of design for assembly, design for manufacturing, design for casting, design for again safety, you will get definitely one theory question for 6 mark from the optimum design. Also you will get in our question one numericals. This numerical we will see in today's tomorrow's lecture. Today we will stop here. Thank you.